Yeah, welcome again to the session. This is about sensitive data services. So this will be by me. My name is Abdurrahman Azab. I work at the University of Oslo. The services for infrastructure services for research. And I'm part of the Nordic Infrastructure Collaboration. And I also work at the Euro HPC Lumi that you will be visiting tomorrow in the user support team, and the sensitive data services at the University of Oslo and the Nordics. And Jorik is working in SURF. You can say a few words.
Well, I've introduced myself earlier this week, so I guess that you should sort of know me.
Yes, he's one of the geeks over there.
I'm one of the geeks of SURF, yeah.
Yeah. Yes, so this is us. And today we'll give you some introduction about sensitive data and data protection. And these are some principles that you need to know as a researcher, because there are some concepts that you need to get yourself familiar with. To make sure that you are doing the right thing when you talk to the patients, if you are dealing with patients, when you deal with data controllers, the organizations, and data processors, etc. And we'll give you some overview about some of the sensitive data services and their categories and their types. When you actually want to analyze or store data, what are the service providers that you need to be in touch with? And we will end with Q&A, so we will try to be fit with the time with this. We will not have hands-on because it's quite tricky to give you access to our sensitive data services for training purposes, but we may try to arrange something like this in the future. But at least you will know how things are working. So there is something called GDPR, General Data Protection Regulation. This is for Europe. And as you see in the text, this is the definition of what is considered as personal sensitive data. There are other types of sensitive data which are not personal. For example, there are some state sensitive data about where the military bases are and about the actual climate and these things, but they are not personal. But when you deal with research, maybe you will deal with some of these data, where are the nuclear plants and these things, but most of the types of data that you will deal with are personal sensitive data. So processing of these, as you see from the types, is strictly prohibited unless it's lawful. So the data protection law for the GDPR, most situation which information about somebody, the personal data of a data subject, and this is the person who has this, or who this personal data is about, is used in some way, that means processed or analyzed by some other person or organization, and this is called the controller. And these concepts you need to get yourself familiar with. First is personal data. Any data that can be used to identify an individual. Name, address, social security number. Not only that, but your genomic data, if there is a sequencing of you, this is considered a personal data. So anything that can be used to identify you is considered sensitive data. And sometimes for genomic sequences, let's say, I can just tell you how serious it is. If there is a very rare disease, and in the whole country you know that there is only 4 people who are infected with this disease. If you do sequencing of one of them and you anonymize the data, but the data contains information that this is about a person who is infected with this disease, it is still considered sensitive because you limit the thing to 4 people. It's one of those 4. So even if this type of data is anonymized, it's considered sensitive. So this is how serious is personal data. Data subject is the living individual, the person, and it's living individual because if the person died, it's not he or she is not a data subject anymore. The data controller is you or your organization as a researcher who takes this data to do some research or some science with it. You can do it by yourself if you have the facilities, if you have the computers, if you have the technology, then you don't need anything else. But if you are not able to do it by yourself and you need some assistance or some technology that you don't have, then you move to the last definition, data processor. And this is an organization, IT organization, normally a third party who has the technology and facilities to process the data on behalf of the data controller. The controller can be the processor, and the processor can contact another processor. For example, your organization is using Amazon Cloud. Then there is sort of a joint contract between your organization and Amazon because both of them are processors in this case. So these are the main concepts. Controllers should ensure that any process complies with the principles, and these are briefly 8 principles. When you do the processing, you need to take care of lawfulness, it has to be legal, fairness and transparency. You need to be very transparent when you analyze the data, when you contact with the data subject. You cannot hide, you cannot mislead, and this makes it legal. Then it has to be limited, only what is necessary. Limitation of the purpose, minimize the data. So if you want to process data about a patient or some individual, you get only what is necessary, not everything about the person. You don't need their life story to process their data. It's illegal, actually, to do that if it's not necessary. Storage limitation, for how long you need to store this data. Once you are done with your research and you publish and you don't need it anymore, you must delete it and don't keep the sensitive data more than what you needed. And then it's accountability. You are accountable for accuracy, you are accountable for security, integrity, and confidentiality, and accountability in general. It's your responsibility as a data controller, because you are the researcher or research organization, your responsibility to choose a data processor who has, for example, ISO 27000 security certified so that they don't have data leaks, because you will carry part of the responsibility if there is a data breach. So these are very important principles. And for you to be allowed to do some sensitive data processing, you need to have one or more of these bases that you are allowed actually to process sensitive personal data. The first one, which most of you will do when you deal with patient data, is consent. So the patient giving a consent that you are allowed to do the processing of sensitive data. In GDPR, consent is not just giving a consent. The consent needs to be freely given. I know that in some countries, they pay the patient to get the consent for. It's illegal. In Europe, it's illegal. It has to be very specific. What are you going to do with the data? What type of processing? To what type of experiment? You cannot just tell them, I want to sequence your genome. I want to get your patient journal. For what? And what is the limit? It has to be well informed. You cannot use that the person is naive to just get whatever consent. If it has been proven that just misuse for example, that the person is naive, not understanding, will just tell you yes, it's illegal and you can be in big trouble. Unambiguous, it has to be very clear. Then another basis is contract. When you have some contract with some organization, if you are a customer of some service provider, then they have your personal data. They have your address, they have your name. If they want to send you some package to your address, they need to have your address to send you a package. So as long as you have a contract with some organization, they are allowed to process your sensitive data to be able to deliver a service to you. So this is another basis. Legal obligation. For example, those who are residents in Europe or anyone who has a passport, the immigration office or the whatever, they need to access to know if you are legal resident here. For example, if you apply for a child welfare benefit, they need to see if you are eligible for that, so they need to process your sensitive data based on legal obligation. Vital interests. If you are in emergency, if you have like a heart attack or something and the ambulance comes and the doctor needs to access to your patient journal to see if you have any trouble so that they can give you medication, they don't need your consent for this because they need to do something urgently, and this can be a basis to access your personal sensitive data. Public task. If there is a public organization from the government who are doing a public task, for example, at the time of COVID, the National Health Institute, they collect information about those infected with COVID and how many people got the vaccine and what is the effect of that. Do they need to plan for another dose? So they process a lot of sensitive data of people to do these statistics and these decisions based on public task need. Legitimate interest, this is another basis. So if you have an account in some system and there is a security attack in your account and they need to analyze some of your personal data to see where are you putting your files, what are you doing, and what is the damage, of course, this is an interest for the organization and also for you not to get your data breached. And this is part of the contract. So this can be also another basis for processing sensitive data that does not require specific consent. And at the end, there are rights for the data subject, the one who this personal sensitive data belong to. For example, for the consent, there is the right of access. You can access your sensitive data at any time. The right to rectification, to correct it, right to be forgotten, to erase, right to restriction, you can restrict this consent, right to portability, the right to portability, it means that you can ask the organization, you have the right to ask the data controller to move your data to another data controller. Please export my data to another data controller. If it is based on consent, you have the right to do that. Right to object. You can withdraw the consent at any time. You can wake up in the morning, I don't feel like that. I want to allow those people to process my data anymore. The reason is to get the data deleted. Yeah, I mean, if you withdraw the consent, yeah, you might, no, it's different because withdraw the consent, it means that they cannot process the data anymore. But they can keep it there. But you can ask for erasure if you want to get that deleted. For example, for legal obligation and vital interest, you don't have the right to object because it's emergency. But this is the matrix for it. So this is a very tiny introduction about data protection. Of course, you can get a course in this, but these are the main important information. Then for the data controllers and data processors, there are types of trusted research environments. including secure data archives where the data is living, and secure processing environment. Those are the data processors who process the data. One example of secure data archives is the federated EGA, European Genome Archive. Before, people used to push their data to a central repository in the UK. And this central repository used to have both the actual data and the metadata about it. Something similar to B2Share. But then it was a problem for different countries to push their sensitive data to the UK. And then they developed something called federated EGA, where the data is kept locally in the country, and the metadata is stored in the central repository. So there are two users here. One is the user who owns the data, who pushes the data to EGA. This is user X, and user Z is the one who wants to access the data. So user X put the data on the local EGA and the metadata about it to the central EGA, and user Z submits a request to access the data. And this is actually the workflow. So first, the data owner submits the data and the metadata to the central repo, and then the researcher submits a request to download the data, and the request is granted. There are two ways for getting access to the data. So you are searching about some specific subject like hair loss, and you find some data sets that you like, some research that you like. Then you submit a request, I want to access this data set. And the data set is in Finland, in Netherlands. There is a data access committee for every data set. They review the request, why do you want to get access, for how long, and if it is approved, they give you a way to download it. Okay, this is located in this country, and this is the way you download the data. Another way, if you are interested in some research, you submit a request, and then this is a more secure way, and they use this in Finland. You don't get to download the data, but you get a remote desktop to access the data, to look at it, and you are able to process it there. So you will be able to look at the data, to analyze the data, but nothing will go out from the infrastructure.
Yeah, I probably need to get your microphone.
Yes.
Yes, thank you. Yes, so I'll just put it in my pocket. Abdurrahman already talked to you about this federated archive. So basically the idea of the federated archive is that you have multiple archives and that everybody keeps their data at their own location. But you also need to make sure that those kind of archives where you're storing the data are actually safe for the type of data that you need, that you are protecting. So basically, also you already saw it a little bit in the GDPR as a data processor. And in this case, storing data is actually one form of processing data. So even the storing of data is already considered processing. So as a data processor, you have an obligation to make sure that the data is safe. And the more sensitive the data is, the more obligations you have. So if it's public data, then a data leak is not really a problem. But if you have very sensitive data, then a data leak is a problem. So to work with these types of data, we have been developing a secure data archive, which is, I'll explain the one that we developed, and I think that the concepts carry over pretty well to other archives. And because I think that some of you, or maybe most of you, are not really aware of what a data archive could typically look like, I'll start with explaining what our normal data archives looks like. I'll tell you a little bit about the problems that we have in terms of storing sensitive data and how we solve that. So Our data archive is based on what you could call ancient technology, but it works really well. It's a tape library. So the storage medium is tape, and there's two main advantages to tape. It's very cheap. It's a factor 10, 20 cheaper than storing on disk. And tape is a very reliable medium. A tape doesn't really easily break. Data isn't really easily corrupted, so it's really nice for storing data. And to make sure that if a corruption occurs, we have the data on two different tape libraries, which are 30 kilometers apart in the Netherlands, so that if something happens, like a big fire or a nuclear attack or whatever, your data is still safe. To use these two tape libraries, which is very inconvenient from a user perspective, we have a layer in front of there. So basically, we call them the data migration facility, it's called, and we have data migration nodes. And as a user, you're basically seeing a normal file system, a Unix file system, where you can store your data. So it's pretty much similar to what you saw, for example, this morning with your B2 drop. You just get a file system on your terminal, you can move data around, you can store it, and your data is safe. There are several ways of using this data archive, from several supercomputers, compute services, from your own laptop, and you can use it with all kinds of different access protocols. So it's very convenient for users to use. However, there's some problems. The first thing is that we built the data archive originally as part of the compute infrastructure of SURF, so the high performance computing infrastructure. And by nature, high performance computing systems always use shared file systems. So everybody is working on the same file system, which makes working with the files very easy, but it also makes it very easy to have a data leak. For example, if you just change the permissions on a file or a folder, it might be readable for every user on the system. So if I'm thinking about our own HPC system, we have, I think, 2,000 researchers on the system. So if one person makes a small mistake, which is just a few presses of a button, you've shared your data with a couple of thousand people. So that's not something that you want. There's multiple ways of accessing the system, which is very convenient for a user, but it is very inconvenient for the perspective of security. Some of the older methods of getting data in or out are less secure than some of the newer methods that exist. Some methods have, for example, encrypted traffic between your laptop and the secure data and the data archive, while other methods don't have encryption. Some methods have access logging, so you know who got data in or out the system. Others don't. So it's really convenient, but from a security point of view, you actually want to have a lot of control. You actually want to say you need to have you need to use an encrypted protocol in which you can do full logging. Another one is that you have interactive access, so you can log into the data archive from your terminal, and you can do all kinds of things with the data. You can accidentally remove it, you can open it, you can read it, you can send it to a different computer. You can, like I said earlier, you can make a mistake with your access rights and other people can read it. So you actually want to make sure that, like, in the end, if you're looking at what is the biggest problem in working with sensitive data, it's not the black hat hacker that tries to get into your system. It's not a very angry person that is going to leave your company and that decides that they want to harm the public image of the company by releasing all of the data that's there. Usually it's a user that is very willing to do everything right but happens to make a mistake. So the entire idea of designing all of these systems is to make sure that those users are not really capable of making mistakes. You'll try to, I mean, it's just us humans, we make mistakes. I do it, you probably do it, and if you say you don't, then you're lying. So by not having interactive access, for example, you prevent an entire suite of mistakes that people can make. And then another one, since it's a very open and public service, basically any researcher within the Netherlands, and by extension any researcher within in Europe, is allowed to use the data archive. You can reach it from any computer anywhere in the world, which, in case you have these kind of black hat hackers that might want to get access to your infrastructure, you make it a lot easier. And then the last one, we don't know what people are doing on the system. So part of what you need to do for protecting the data is making sure that you know that people don't have unlawful access to the data. You need to make sure that people only use the data for legitimate purposes, but if you don't know who is using the data when or why, then you have no idea if people are actually keeping to their contract. So how did we solve that? As you can see, up until here, we have used the same infrastructure, what already exists. But we made a couple of changes to circumvent each of the problems that I just described. So as you can see, it might not be very clear, but in my previous picture, you saw that all of the systems had a single connection to the disk pool, to all of the data. In the new picture, we have separate connections. So we make sure that all of the data is segregated. So instead of offering a shared file system in which everyone can see all the data, you can only get access to the data that you are owner of. So even if you would make a mistake with your permissions, with your access rights, you will never see data of other persons will never see data of you. It's a very simple change, which actually has great implications in terms of data security. And then the next one is that instead of having, because this isn't a shared file system anymore, but what we even did is we made sure that people are not living on shared systems anymore. So instead of having one service node or one location that you can use to enter your data on the data archive, you will get your own virtual machine. So every project gets their own virtual machine with access to only their own data. So this virtual machine will never see what happens on this virtual machine, and this file system will never see what happens on this file system. Which covers most of what we already saw, most of the problems. And then there's two relatively little changes that we also made. So one is that for every project node, since every project node is only meant for a single project, we can also put a very restrictive firewall there. So what we do usually is we only allow a very small IP range to enter the project nodes, which would basically mean we're going to ask any of the users with the sensitive data, can you tell us the couple of users that needs to get access, or maybe the institute that needs to get access, and then we can do something like you can only access from the office network, for example. So only if you are logged in on a PC on your institute's network, or if you're using a VPN to go to your institute's network, you are allowed to enter your data. If you are somewhere on a beach and you don't have any proper access to internet, then you don't get access to your data. And then finally, we only allow a single access protocol. So you're only allowed to use SFTP to move your data in or out. You're not allowed to SSH into your project node. You're not allowed to use tools like SCP to copy your data. You're only allowed to use SFTP. And there's two reasons for that. The first one is we have full logging on SFTP. So every byte that gets into the secure data archive, but more importantly, every byte that gets out is logged. And by default, you have an encrypted channel. So that way, all of the data is moved in and out very securely. This is by no means a blueprint for how every secure data archive, what it looks like. It's more or less meant as a sort of primer for you guys so that you kind of understand what kind of restrictions you would probably have when you're going to work with secure data. Because the systems are designed a little bit differently than other systems, usually with good reasons, but as a user, it's really hard to hide this kind of security hardening for a user. We try to make it as simple as possible, but you will always get certain limits. And then
yeah, so this was about secure data archives. And actually, the concept of an archive, it means that the data is not in process anymore. And this is a very important concept, because when we talk about B2 share, B2 drop, this is not archive data. This is data that is still in process. But B2 safe might be something for archived data. Archived data might be raw data, which is not changed anymore, or results that are not going to be changed anymore. So this is why you put it in the archive, and it has to be always stored in a secure place and has to be also encrypted. Now, the secure processing environments, when you take data out of the archive to do some processing. So normally, the data lives in the archive, and this is for 10 or 20 years or decades or whatever. And then you take it to the secure processing environment. Normally, the project lifetime can be a few months, a few years, maximum 10 years, I think, for all of the systems that I'm aware of. And after the processing is done, then you take the results, put it in the archive, and delete it from the secure processing environment. What is very important for this secure processing environment is to be secure. And security, it means that it is secure against external attacks, so that no one from outside the system can manage to see data inside the system or access to the system, and from internal intrusion, so that researchers from a specific project cannot see data from another project. So it has to provide efficient internal and external isolation. And of course, should have good tools for data processing, but security is more important. TSD, Tjeneste for sensitive data. Tjeneste is a Norwegian word for services for sensitive data at the University of Oslo, is one example of a secure processing environment. And in TSD, it's a box. It's like a black box where you get there and you get everything there. So this is one example of a secure processing environment. Yoriko is going to speak about SANE, which is another type of secure processing environment, where it is ideal, it's a portable solution, and it is ideal for data sharing, secure data sharing. But here we are not focusing on secure data sharing. It's your data, you are going to process it with your group, with your fellows, will be in one project. You will make sure that you get all the tools that you need, and also the isolation from attacks or breaching. Let's see if we have a voice here.
Hi, meet Lisa and her team, researchers at the University of Oslo.
Okay.
They work on collecting, storing and analysing personal mental health data imported from web-based questionnaire system, smartphone applications and dictaphones, fMRI and DNA sequencers, and therapy session video streaming. Lisa is proud of her team as they do a really great job. But hold on, such huge amounts of collected data will take ages to analyse, and as new data keeps on coming, they already have difficulty to store it all on their local server. What makes it even harder is that such sensitive personal data requires an exceptional protection by law. This is what TSD, Services for Sensitive Data, was created for. TSD is a safe private cloud e-infrastructure to collect, store, and analyze sensitive research data that requires a very high level of security. It gives Lisa and her team easy access from anywhere in the world, allowing for cooperation with users from outside the campus, and offers a wide range of software, databases, video analysis tools, automated data processing, a supercomputer, and high-capacity storage with backup. All this makes their work super easy, super fast. Whereas Lisa can sleep comfortably, not worrying about data security. TSD is made to provide a secure e-infrastructure for any researcher who needs to use all its utilities with high-performance computing. Or just one simple Excel sheet. TSD, enabling a new and improved research in a secure, flexible and cost-effective manner. Join us at uio.no/TSD.
Yep. So you are Lisa. I'm that bald guy who was sitting with, I'm not quite bald yet, but this is us who are taking care of the data while you are sleeping. Yeah, so what can I just say? How do I remove that? Oh, yeah. Yeah, this is also very important, how to get a project in TSD or other similar sensitive data services. First, you need to prepare a case and to start a project life cycle, a project in our system. So once you apply for a project and it is accepted, and I will give you the steps how you get your project accepted, then you get user accounts, credentials for the project PI and other users, fellow users within this group who will have access to this data. And you need to collect consent from the patients. We provide this service to you. So you don't need to go with the paper to the patient in the hospital and sign. There are some ways that the patient can provide and withdraw the consent electronically if they wish to, using their mobile phones. Collect the data and consent. Then you can start analyzing the data and publish the results and be able to share the data with others. So if you want to share the data, there are ways to share the data with specific individuals who will log in with their bank account and or their user ID with two-factor authentication. And then you can go to this cycle again, collect data and consent, and then analyze the data, publish the results, and go in this loop until the end of your project. Usage patterns. So the simplest way is primary interface is remote desktop. And there is file transfer via RESTful API. This is how you import and export the data. Normally, everyone in the project group is able to import the data. But who has the right to export data? Normally, it's only the PI. Or the PI can give this right to some other individual from the group, but has to write a specific declaration for that, that this person has the right to export the data. Because this is what is dangerous, right, to take the data out. You can do HPC, high-performance computing, within the system. You can run containers, like Docker containers, your own tools. You develop your own tools and get them in, and you can run them. Custom application development, you can develop your own applications and run them in the system. And this is how it works. So you get a remote desktop from using Windows or Linux, and you get through the gateway. You have a storage there, and these are virtual machines, Windows or Linux virtual machines, and you have access to HPC. Colossus is the name of our HPC cluster, where all of the HPC workloads run. And this is how it looks like. This is the window where you get your login or register or apply for a project or apply for a new user, and then the PI can approve your request. And then there are interfaces for uploading the data, and there are forms for submitting consent. And then we have the analysis tools on the HPC system, and the TSD publication portal is the tool for sharing data sets with externals. You can share your data sets with users from the system who belong to other projects or other groups, or you can share the data with someone who is completely external in the United States, or probably not in North Korea, but there are some blacklist of, you cannot share the data within this region. But otherwise, you can share the data, and we make sure that this is the person that gets the access. In order to get acceptance for your project to use a secure processing environment, first you need to get something called ethical approval. And this depends on your country. So in Norway, we have the RIC, and there are two organizations, because there are two types of data for the health data. There is the clinical data, the data that is used to provide treatment for patients who are getting the treatment right now. This is called clinical data. And here you need to get two approvals. One from the research authority and one from the health authority. If it is research data, the patient is not getting the treatment right now, but this is a person who is still alive. Then you need to get approval from, ethical approval from the research authority, not the health authority. Once you get this approval, you submit this through a portal that verifies that it is you, and then we review this within 10 working days. It can be more, it can be less in other sensitive data services. No limitation who can be the PI, can be someone from the US. And we have different pricing for different affiliations. Some people get it for free, some people need to pay. For the EOSC users or the European users, we give them some quota for free, so you can get some quota for free in TSD. The project rules. One is the principal investigator of the project, the leader of the research group, is the initial applicant responsible for project setup and rights management, and the rights, admin right to assign or remove rights, export rights of data, custom to manage custom file access. You can say that these people from this group have access to these files, etc. Data collection, how the data can be collected. There are different types of data. One is structured data, data that can be displayed in table, Excel sheet. And you can put it with records, like surveys. Unstructured data, like genomic data, which is text or binary. This is unstructured data. There is also automated data import. If you are a patient or someone who has this what's called health monitor about your heartbeats, how many steps did you eat, what did you walk, and how did you do today regarding the all of these sensors. This is automated data import. It can send these signals with the data automatically to TSD, and it is received and it is recorded, and the data is sent to your doctor and gives an alarm if there is something. Web app mobile development. You can develop your own application and use the TSD API if you are able to do that, and there are some mobile applications that you can use developed by us. Dynamic digital consent. Patients can submit or revoke consents with this tool. And secure video recording. There is a lot of data that can be sensitive for video recording, like the use case that we had for the data management plan example. This is a sensitive data, and some data can be even more sensitive, like people who are refugees and they are telling their stories. And if this story is like revealed to someone from the authorities in their home countries, there can be some life-threatening. So it can be a bit very sensitive and too sensitive compared to other data. So it has to be very secure. Extensible services. You can design your own services that uses the API for collecting the data. NetSchema or the web form is one way of collecting your data. If you go to this netschema.no, there is two ways of logging: the national academic logging, which is called FIDA, and log in using TSD. MED means using TSD. And then you will get a screen that you need to accept the rules, the GDPR rules and the local legislation rules. And you need to have a TSD account to create this form. So this is a form to collect data from patients or from other individuals that are considered sensitive and treated as sensitive data. And this form, the result is an Excel sheet or some other type of tabular data that you can use as structured data. For unstructured data, for data files, there is this interface for uploading your files through TSD. And you can use this portal, or you can build your application using this API. And this is a small example how we use the API client. So you can design your software and give credential to the software. The credentials are tokens, OIDC tokens, which are electronic identity that defines who you are and what types of access you have. And it's a short life token, so that if Yorick told you that most of the problems are from the users, from you, I mean, not you, but the users who don't deal with security in a in a serious way, so that you can share your token with others. You might not use the mobile phone for two-factor authentication. Some users, they just install an application on a virtual machine so that they want to use their laptop for everything, eliminating the purpose of the mobile phone completely to make life easy for themselves. They make it less secure. So it's important to be careful with these electronic identities. And this is the interface for the video recording. You have a screen for recording monitor and capture monitor if you want to capture some images, and take this recording into TSD in video files where you can have them indexed. And also there is the TSD API for application development. This is about the consent automation. So this is how the patient sees. So these are the types of consents that the patient has. Either it's still not approved, or it is approved and it is possible for the patient to revoke this consent. So the patient has this external portal where he or she can log into the portal through the internet, through the mobile phone at any time, and approve a consent or revoke a consent. Can change mind. Approve it today, revoke it tomorrow, approve it after tomorrow. According to GDPR, they can do that. Yeah. And then this is for the project manager. So for you as a researcher, before you do any analysis to data of a specific patient, you need to open this portal and see, is the consent given? Is it still valid today? Can I do analysis? If you see that the patient changed his or her mind, you are not legally allowed to process this data. And we will not allow you to process this data, so you will not find that you are able to access the data if the consent is not active. And of course, as I said, the right to be forgotten or the right of erasure is some other thing. So if the patient applies that I want my data to be erased, then the data is deleted completely. Yep.
Cool, thanks. So first things first, we've been sending a lot of information your way, we know. It was hard to make this a more interactive session, but I would like to know if there's so far any questions, like any burning questions that you have, things you want to discuss. Yes?
I think my question is quite stupid, but...
There are no stupid questions. There is
Thank you.
I was wondering, is there a time granularity for revoking the consent? Because a user cannot change the consent every second, right? That would be...
Yeah. As with anything that has to do with the law, this is a bit vague. So you are allowed to retract your consent and the processor has to adhere to your right to do that. And then the law states that that needs to be done within reasonable time. And within reasonable time is a lawful thing that actually works within the law, but in practice it can be very difficult. The reason for that is that it really depends on the situation what is a reasonable time. Because, for example, if you're looking at the right to be forgotten, there might be a lot of things that need to be forgotten. And depending on the processes that are there, can be it can take a certain time. Nice example, for example, if we look at the data archive at SURF, the way that we handle our tapes means that data will, after we've deleted data, it will live on our systems for 30 days. There's nothing we can do about that. That's basically that's the way it is. That's the way the systems are designed. So, in our case, if you use your right to be forgotten, it is reasonable time that we delete your data within 30 days plus a certain response time to your request. However, if we would take 6 months for that, that would be completely stupid. On the other hand, if you have a different kind of system, then it might be that only 2 or 3 days might be a reasonable time. And it's similar with data, like you have the right to request all of your personal data. So if you have a recruitment agency, for example, they have a file on you. So if you request your personal data, they should just pull up the file, give it to you, and it shouldn't take more than 1 or 2 days. However, if you request all of your personal data at Facebook, then they will have to prepare probably 150 gigabytes of data. So then it is more reasonable that they would need, for example, a couple of weeks for all of their systems to have collected this data and find a way to send it to you. So that's why there's no strict limits there in terms of time. It's all reasonable. And if you as a consumer think that what your processor is doing is not reasonable anymore, then it's your lawful right to go to a judge and ask the judge to judge whether this period is reasonable or not. But usually so that's also why as a processor you really need to make sure that you think about all of these processes, because you can take 3 months to delete somebody's data, for example.
I have a question regarding the form that the patients agree or disagree. Let's say we have an 80-year-old patient. How does it get handled? I mean, does people in the hospital that do a research handle their accounts? I mean, how would a person without a smartphone?
You have a patient who's what?
80-year-old patient.
Very old patient, yeah.
Doesn't even have a smartphone. I mean, is it legal for the hospital to create an account for them and a nurse, let's say, or a manager accept or not accept the practice?
There are local or national legislation for this, because, for example, in Norway and also in Germany, if the patient is not able to provide information or provide consent, because, for example, before you do a surgery, you need to give a consent for some things, if there are allergies or something. If the patient is not able to do that, then someone from his or her family can be authorized to give on their behalf, some sort of guardian. And the same for a child, for example. And one very important thing to know, that GDPR, what I described in data protection, is called General Data Protection Regulation. It's general, but what makes it specific, like what Yorick described, it's the local legislation. So you have the right to be forgotten, but how this is interpreted, it is the local legislation. How long you have to submit the revocation of the consent. It can be different from a country to another and from a system to another. So GDPR is very general. It says that the system should be secure. There has to be encryption. But what type of security, what type of encryption? It doesn't mention it. So who defined this? It is the local legislation.
Yeah, that's indeed a very valid point that Abdulrahman raises. So the GDPR as such is not really, So everybody is always talking about that you have to adhere to the GDPR, but in the end, the GDPR as such is not enforced. It's every country has their own law which follows the principles as set by the GDPR. So be sure that if you're looking into security or like into practices that have to do with handling sensitive data, that you look at the legislation of your own country or the country you're working in. And like we said on the session earlier this week, don't try to reinvent the wheel here. I know that every university has an ethics board. Every university has people walking around that can help you with dealing with all of this information. So really go and find those people. Marianne.
Question about TSD. Is it, in terms of the consent, is it focusing on the clinical scenario, so medical data on patient, or is it also provide support for other kinds of sensitive data? You mentioned refugee interviews, for instance.
Yeah, there are different types of sensitive data. So TSD is not only for biomedical sensitive data. There is social sciences and there is climate data that can be sensitive, and so all types of sensitive data are within the scope of TSD.
I think I was a bit sidetracked by the option of the referral information, because that is clear where medical staff can refer contributed persons.
Yeah.
That's why I was wondering if that's strict for the focus is much higher.
There are some sensitive data infrastructures in the Nordics and in Europe which are only for biomedical sensitive data. Most of our customers in TSD are biomedical sensitive data, but it's not all.
Very good. Thank you.
Yes. Okay.
Can I ask a final question?
Yeah, of course. No.
The consent form is for the general use of data, or for its research, someone has to consent for the data to be used on that specific research?
It should never be a consent for a general use of data, because then it is illegal. Because it has to be specific, if you remember that slide. So what are you going to do with this data? What type of research? And you need to describe it very well to the patient so that you are limiting the scope and telling that this for this specific use. If you need to use it for another thing, then you need another consent. Actually, there was one of the big problems that we had in one EU project that we got funded, EOSC for Cancer. And there has been a lot of data that has been collected for a specific type of processing for cancer. And we had a very long debate with our data protection officer, can we use this consent for that type of analysis for cancer? And at the end, it was not possible. So we need to restart this process from the beginning.
I think this is very crucial in the discussion about reusable data.
Yeah.
Because almost by definition, this data is not reusable beyond the specific project.
Beyond the specific scope, yes.
And the right to be forgotten is about the whole system, right? Because you cannot just take back your consent and ask for the right to be forgotten on this specific research. Like you can withdraw all your data from the
Yeah, but you need to differentiate between withdrawing the consent and the right to be forgotten.
It's two different
Withdrawing
things.
the consent, I don't allow you to do any further processing for my data. But to erase the data, I want you to delete it completely. So maybe you are not comfortable with processing your data, but you have no problem to keep it as long as it is secure.
I mean, I was earlier talking about this recruiter that has your data. If you want to be really, if you really want to be nasty towards a recruiter, you should just ask for them not to process your data, but to keep it. So they have the obligation to keep all of your data safe, but they're not allowed to do anything with it. So you just exercise one of your two rights instead of both. Haven't told you that. So let's continue. So Abdurrahman just described a system in which people that are using, like if you own sensitive data, or if you're working in a project where you have sensitive data, then how to work with that, right? So you get your own infrastructure, you have your own data. But there's also a second class of use cases, and that's where somebody else has sensitive data and you want to use it for your research. And we are currently building in the Netherlands a solution for that, and we are also in a process together with Abdurrahman to get this into a European context. Not contest. It is a contest, but so what I'm going to show you, it exists. It's not. I mean, if you're going to Google it, you're not going to find it. We're making it public in September, so that's also the reason why we couldn't use it for a demo today, unfortunately. But hopefully in the future we can. So, as we already said, there's different categories of sensitive data, and the obvious one is, for example, personal data and medical data. But medical data is very interesting for processing. But what you quite often see is that, for example, if you have an academic hospital, they have a lot of medical data. They are very open to sharing it for research purposes. But the problem is it's their data. They have the obligation to keep it safe. And if they give it to or if they provide it to an external researcher, and that external researcher makes a mistake and actually publishes the data, it's the problem. It's not the problem for the researcher that made the mistake. It's the problem for the hospital that owns the data. So by providing access to their data set, they're basically taking a risk. And that's something that hospitals don't really like to do, because taking risks with medical data is a very expensive risk. You have a big problem if somebody leaks your data. But that's not the only type of sensitive data. We are also working together with the Dutch National Library, and the Dutch National Library has a lot of resources. They have a lot of content which can be very nice to use for research. However, all of this material is copyrighted, all of this material has, the rights are not waived, so you can give people access to the material, but if they accidentally leak it, you have a problem. You're infringing the copyright of I don't know how many people. And then there's a third kind of sensitive data, and this is it's less common than you think. This might actually be one of the most common types of sensitive data, but it's the type of sensitive data that's almost never shared because of a very stupid reason. So the example here is the Dutch Chamber of Commerce. And the Dutch Chamber of Commerce has information about every single company in the Netherlands. And the way the Chamber of Commerce earns its money, and they earn a lot of money, is by selling this data. So if I want to know something about a company, so let's say I want to acquire a company, I want to know certain things about the company, I want to know certain information about the owners of the company, I can go to the Chamber of Commerce, I can ask for that data, I pay a couple of €100 and then they will provide me with this data. So if I am a researcher and I want to do research on a certain field, or on, let's say, I want to see why certain companies go bankrupt, I want to get all of their information, I have to pay a lot of money to the Chamber of Commerce, which makes that kind of research not really feasible. However, the Chamber of Commerce doesn't want to share this data for free, because if I accidentally leak the data, then they lose their stream of revenue, because then all of this data is available without people paying. So basically they have an interest to keep their data safe, because otherwise they won't make as much money. And that's also why I said this kind of sensitive data exists a lot. So here we have 3 use cases of people that actually have very valuable data, but also have a lot to lose by not sharing it. And that's the reason why they are not sharing it. So basically what they're saying is, I'm willing to share my data, but I can't because I don't want to take the risk. And we are building a platform in which we say, okay, but what if we can minimize your risk? Are you willing to share your data then? And we have had a couple of people that said yes, and we're building a platform with them. So I'm going to quickly describe 2 use cases here. that we use for building this platform. So the first one is the Dutch Chamber of Commerce. So I already used them. I already explained why their data is sensitive. And they said, we are okay with sharing our data, but we want to keep in control of our data. And that's basically the same. That's basically what you hear in every use case that we are discussing in this context. Basically, they say, I'm okay with sharing the data, but I want to be in control of my data because I don't trust others with my data. If I give my data away, I might lose it. As long as I keep in control of my data, I feel safe. So they want to have an environment in which the data is kept and the data is not allowed to leave the environment. They want to be able to control how the data is used because, like I already said, they earn money by selling data. So they only want to use their data for research purposes, non-consumptive use. You're not allowed to gain anything besides research interest from this data. And to make sure that all of this happens, they actually want to review any output from the system. So basically, as a researcher, I'm allowed to see the data, I'm allowed to use the data, but I'm not allowed to release any data. They want to check before I can release any data. And then, because it's they are okay with, basically they say we trust the researchers, we trust their software as long as we have a safe environment. On the other hand, we have the Royal Library. They have similar, there's a couple of small differences. So also the Royal Library wants to have complete control over the data. The data is not allowed to leave the environment. They want to review output, and they want to make sure that it's only used for a research purpose. However, they want people to be able to process the data without seeing the data. So basically, they want an environment in which you can upload your script. It's run. You never see the data. You just get to see the results after they have reviewed the results. So it's kind of similar to what we need to do for the Chamber of Commerce, but it's slightly different. So basically, where for the Chamber of Commerce, I get to play around in a sandboxed environment. We call that tinkering. You get to tinker with the data. With this use case, you're blind. You can just fire a script, you can see the result, but you will never see what the script saw. And another one is that since data is not allowed to leave the premise of the Royal Library, the solution needs to run on-premise for them. So they don't want to run in a cloud somewhere, they want it to run on their hardware. So the solution that we have built is based on the 5 saves principle. This is something which is developed by the UK Data Services, and later on you'll get the slides and then you can look into this a bit more if you want. But basically, the 5 saves principle says that I made a typo. The 5 saves principle basically says that you need 5 things for any sensitive data services. So you need to have safe data, which means that you need to encrypt your data and that you need to save it in a safe location, basically. So like we discussed earlier with the secure data archives and the secure infrastructure. You need to have safe projects. So it's not only about keeping the data safe, but also about using the data in a safe way. So this is, if you saw the project lifecycle that Abdul Rahman just showed, the first stage was actually talking with the researchers about what they want to do with the data. You need to make sure that they're going to use the data in a legitimate way. Safe people, make sure that the people that actually get access to your data, that you trust them, because there's always a very important trust relationship here. Even though you are opening up your data in a safe environment, you are opening up your data. If you want your data to be safe, you need to delete it. If you want your data to be almost super safe, you need to never share it with anyone and just leave it somewhere in a deep dark corner of your server. But if you're going to share your data, you need to trust the people, because if you can't trust them, they will leak your data. Safe settings. So safe settings kind of goes back to the point I made earlier. people make mistakes, prevent that from happening as much as possible. Make sure that you build an environment in which people can make mistakes without it having any repercussions, or or try to minimize in security we often say that you need to minimize the attack vector. So make the attack, the surface of attack of your system as small as possible. I would say try to make the mistake, like the plane on which people can make mistakes, as small as possible. And then the last one, safe outputs. So even though you have these 4 principles to make sure that your data is safe, that the projects are safe, that you trust the people, if you check outputs, if you check any data before it leaves the system, then you'll be sure that nothing will ever be leaked. So these are the guiding principles for this system. And the system we built actually looks quite a bit like what Abdulrahman just described. So basically, as a researcher, you get to enter the system via a remote desktop environment. The system itself is running on a cloud. You have sensitive data, which is provided by external providers. You're not allowed to see it or to use it. Or, well, you are allowed to use it, but you don't own it. The data provider keeps in control of the data. Quite often, but it depends on the use case, you are allowed to upload your own data so that you can combine data sets, although in some use cases that's not really allowed. You get some analysis tools to do whatever you want, and then there is an output check, which is part of the release process. So this is kind of the concept. So what does that look like in real life? So basically, SANE, that's what we call the product, the Secure Analysis Environment. Yet another stupid acronym. Consists of 3 parts. We have a data owner portal. So like I said, the data owner is in control. So they get their own environment here in which they can decide who gets to see what data. And then there's 2 different user environments. We have the Tinker workspace. So that's the workspace I just described for the use case of the Dutch Chamber of Commerce. You get to log into your workspace, get to play with the data, but they are in control what goes out. And you also have the blind workspace, in which you're only allowed to run containers or use scripts and stuff like that. So what does that look like? So the data owner portal first, it's quite simple. It's a Linux virtual machine. You log in using 2-factor authentication, because what else would you do? And then you get a couple of folders. So basically, for every project that wants to use your data, you get a folder, and you can upload the data that people requested in that folder. That way, you are in complete control of the data that is shown to every user. You are the one getting the data from your safe systems, putting it in this safe system, but you actually do the data movement yourself. So there's no real trust relationship here, because you are the one in control. Then the 2 environments for the users. First, the Tinker environment. Again, you start with a remote desktop connection. And the advantage of this remote desktop connection is that we can make sure that you get access to your system, but there is no way of getting data in or out. It allows us to completely seal off the system. So remote desktop connection, then 2-factor authentication to get into the system, and then you just get a normal Windows virtual machine. And on this virtual machine, we have installed some tools for you. As you can see here, for the ones that are familiar, this is RStudio. So you can just use RStudio and play around with the data that you got access to. You can see there on the top, there is a Windows Explorer screen. So in this Windows Explorer screen, you will see the data that is provided by the data provider. And you get to play around. But if you try to go to the internet, that won't work. The machine is completely shut off from the outside world. So even if you are running unsafe software, that software that tries to send all the data in the virtual machine to the external world, it's not possible, because there is no connection to the outside world. And then, yeah, like I said, you get access to data. You will also have a folder for results. So once you're done with playing around and you have a set of results that you want to use for your publish, for example, for your research, then you can contact the data owner. You can say, if you look in my results folder, you see what I want to release. They can have a look themselves, see if there's any data in there that they don't want. And then if they agree, they will send the data to you. And then there's also the blind environment. So in the blind environment, you're not allowed to see the data, so you don't get this, this remote desktop experience. Instead, you get a wizard. And in this wizard, you can basically say, okay, I want to build a machine. You give it a name, and then you can give it some parameters. So we support two things. So one thing is you can create a Docker container. So in this Docker container, you can do any analysis workflow that you want. We will download the Docker container for you. We will mount the data in the Docker container. We'll shut off the Docker container from any outside interaction. So even if you have data in, if you have processes in there that try to send out data, that's not possible. We run the result, and then there will be an output. We will create an output, and then all of the outputs that you've generated will be sent to the data provider. The data provider can have a look, and if they agree with releasing the output, you will get it. If not, or if there is a mistake, you'll get an email with extra information about that either your output was rejected for a certain reason or that there were certain problems with your script. This one was added by you, I think.
Yeah.
I was like, whoa.
Yes, so this is a community for sensitive data that has some researchers, system administrators, lawyers, and funders and service providers. We have it under NAIC, the Nordic Infrastructure Collaboration, but we have a lot of European members. So we normally have one workshop a year and some datathons and some webinars for teaching about data protection and also about services. We are planning to have more hands-on workshop on sensitive data services. So if you are interested to join the community, just subscribe to this mailing list. We don't send that many emails, maybe once a month or something. Yeah. Okay, so this is the conclusion, and remember the lessons to take home. Remember these rules of data protection. Also for your own use, I'll tell you just a very short story. One of my colleagues, he called some insurance company, and this is in Norway, and they are recording the call, but there are two languages, Norwegian and English. And they say in the beginning, in Norwegian only, that this call will be recorded. And then they ask you to choose between Norwegian and English. And then he made a deal with them, and then they sent him an invoice, and he said, no, from his perspective, he did not make the deal. No, you made the deal, we have the recording. And then he said, no, you did the recording after a Norwegian information that you are going to do the recording, but the conversation was English, so your recording was illegal because you did not inform me in English that you are going to do the recording. So, and then they closed the case immediately. Otherwise, he could sue them. So it's very important, these rules, and the most important thing about GDPR is the fines. So you will not go to jail if you oppose them, but you will pay a lot of money. Probably you will go to jail because of not paying the money, but right? Also, very important to choose a data processor that is approved by the authorities, and they have to be implementing very strict data isolation, because if data leak happens, and it is known, it can be a scandal for them, and the researchers will be also included. So make sure when you write or when you sign contracts with the data processors that they take the full responsibility and read these. Don't just, like the regular users, accept you just scroll down, accept. No, you have to read very well and make sure that you are doing research for a good cause, but don't get caught by these strict things because of being, yeah? Yes, I guess we have some time for questions, discussion.
Whatever.
Is there any type of form or a normal type that we have to write to make a good consent form, like in the TSD?
Yes, indeed.
Is there some sort of format for us to use because I personally don't know how to write a good consent form to be safe and legal. Is there some sort of format?
Yeah, this has to be by the data protection officer. And normally every data, because the data controller is not you as a person, you are a researcher, but it is the university or the research institute that you are working in. Every university or research institute who is dealing with patient data or sensitive data, they must have a data protection officer. And actually this concept, data protection officer, it has been introduced generally first by GDPR. So this was a new type of job that people should have, and there is certification, ISO certification of data protection officers. So it has to be the data protection officer in your university or institute. He or she must exist, and this is the person to consult on how to write the consent. Yeah.
Yeah, that's a nice thing. You're not responsible. It's always somebody else. Now, this is really one of those cases where you would talk to your department. Like find your data supporter, and I'm going to shamelessly plug my talk from earlier this week. When you're writing your project proposals, when you're writing your DMP, that's the time when you think about stuff like this. Then you should talk to the data steward, then you should talk to the ethics committee, then you should talk to the data protection officer of your faculty, and then they can really help you with this. And I think also in your case, I mean, most of you are PhD students, do also shift part of this responsibility on your supervisors. They have dealt with this for a long time in their career. I mean, for you, like if you're doing your PhD research, that will probably be the first time that you have to work with consent forms. I mean, it's the first time that you're actually going to gather your own data. Usually, as a master's student, you get a data set. You don't really have your own research. So there's many people before you that have done this, especially if you are working in a field in which it's very common to, like if you're working in the social sciences or if you're working in the medical field, it's very common to work with consent forms. So your university will have consent forms that will adhere to all of the different rules and all of the processes that we just discussed. And you can just trust that if you use that, then you should be fine, because ultimately it's the university that's responsible. So as long as you do everything that the university wants you to do, they will take the responsibility if anything goes wrong. And that's also why we always say don't invent the wheel yourself, use the processes that are there, because ultimately they're there to protect you. So that when you make a mistake or when something goes not as you expect it to go, then there is somebody else that takes the blame for you.
And one important thing to remember, don't think that if there has been a procedure in your organization that has been going on for some years, that it means that it is correct. Maybe your supervisor have been doing illegal data collection for years, but no one complained, because the case will be opened once someone complains about it, when there is a case about it. But if there is no case, it does not mean that there is no violation. And the same goes for security. One could claim that my service is very secure. We didn't have a single data breach. Said whom? Said the service provider, because we didn't have a case. Maybe you had thousands of breaches, and there have been a lot of hackers who got access to your data, but none of them made a scandal. Hello, this is the data I got from there. It didn't happen. This does not mean that there has not been a data breach. So, as Jurek said, take less responsibilities as possible. Make your supervisor take this responsibility. If someone should go to jail, shouldn't be you.
But feel free to speak up if you ever
Yeah.
see this, because it is to what one says. Sometimes people don't know. So if you happen to know that what your supervisor is doing is questionable, if you feel comfortable, try and start a discussion with them.
From the perspective of data service providers, is there any catalog providing the document guidelines for ethics committee on each discipline or data protection in each discipline? Because social science and life science might be different regarding mentioning about sensitive data, and even in the life science it might be very complex.
So, correct me if I'm wrong, but I don't think that there will be, usually it's kind of layered. So the nice thing about something like the GDPR is it applies to everyone. You can't really pull the my discipline is different card, because every discipline has to adhere to the same set of rules, because the protection it's not from the protection of the research, it's from the protection of the participants in the research. So you can't really pull that card here. But then again, you see that there's more and more initiatives, because everybody is dealing with the same kind of problems here. So quite often you will see that communities as a whole try to do things the same way. So usually a department in a university, university says, okay, we are responsible here, but the board of directors is ultimately responsible, but they will not take, they will not do the day-to-day operations there. So they will ask the faculties to do this. And then usually at a faculty level, because also a faculty is usually within a single discipline, they will have guidelines for you as researchers. And then that's quite often supported by, for example, European guidelines. For example, last week, earlier this week, we showed the ethics guidelines for from the European Commission. Every researcher in Europe is supposed to follow these guidelines, so then these guidelines are a good starting point if you want to look at that. But yeah, usually I would say start talking within your department, because your department is the place where all of this starts. And if you are part of a central body of the university, for example, if you're part of a library, then usually you just talk to the data protection officers that are working around in the library, because quite often the university-wide policies are actually set at the library in this case.
And also another option, if there are European-wide services where they have agreements in different countries, like the Federated EGA, they have operational services in several countries in Europe. So the rules and regulations that they put in their website, for example, if you go here for the submission, there is DAC, this Data Access Committee, and it contains documentation about what needs to be done for providing access. Normally, with this platform, it means that it agrees with the local legislations of all the countries which are members of the Federation. So you can go to this webpage, egaarchive.org/federated, read, you will see how the guidelines of submitting new data to the archive, accessing the data, some information about legislation which are quite general. Yeah.
And I think I saw a question at the back.
My question is it proper for in an organization for all staff to have access to sensitive data, or for some certain data processor, or for certain persons in the organization to be in charge of protecting data or something?
You mean that sensitive data processor's responsibility?
Yes. In terms of handling sensitive data, is it proper for all staff, maybe staff of an organization, to be able to have access to sensitive data, maybe in a material organization?
No, usually not. At least, if I understood your question correctly, you wanted to know if it's okay if everybody within an organization has access to sensitive data. No, so this is actually in violation of the GDPR. So I'm not completely sure which article of the ones that we discussed, but you have to have a good reason for processing sensitive data, and you have to limit the processing as much as possible.
It's the limitation principle, actually.
Yeah, the limitation principle. So unless you can explain and you can actually argue that every single person in your organization needs to have access to that data because every single person in the organization is involved in the processing task of that data, that would be the only reason for every person to be allowed to have access to the data. But then I think you will have a pretty hard time to, for example, if you have somebody that works at the reception desk, to make a case that the person at the reception desk needs to have access to genomic data of every patient in your hospital, for example. So here you have to, like, this is a red flag. If everybody has access to sensitive data, it's a red flag that somewhere this limitation principle is violated.
And I can give you an example. I have been working in TSD before the GDPR and after the GDPR. So I'm an admin from the TSD core admin team. So before the GDPR, I had the right to access all sensitive data of everyone for administration purposes because it's easier for me to do the job. After the GDPR, this has been limited. So if I need to impersonate a user and to be able to reproduce a problem, this user has a bug or error, so I need to log in as the user to be able to reproduce. It has to be a written consent from the user for me to be able to solve. If I do this without that consent, I'm in big trouble. Yeah.
I was wondering about, for example, databases that don't give open access to users unless they are premium users, pay something. So these are not sensitive data, right?
You mean the commercial type of data that you need to pay to get access?
Over, genome and variants and databases like that are not open for researchers, but they commercialize their content.
Mm-hmm.
This can be considered sensitive data, or since again the user will pay and have access, is not sensitive data.
The definition of personal sensitive data, remember that anything which can be used to identify a person. This is what is considered personal sensitive data. And anyone who processes this data needs to have a legal basis. Anything else that cannot be used to identify a person, this can be sensitive for a company, for example, because this data, they sell it and it's valuable for them, so they don't reveal this data before you pay the money. But it is not considered, according to GDPR, as sensitive personal data.
So if I'm a company, let's say, and I want to incorporate data sets from EGA for my premium users, I cannot do that because EGA will not even license this to me, even if I pay.
Yeah, because there is a data access committee, in EGA there is a data access committee for every single data set.
Okay.
So anyone who upload, if you go to the demos for submitting data to EGA, you need to define, when you submit the data, who is the data access committee. It can be one person or more who will get the information, or the request will be forwarded to them from anyone who wants to access the data, including who is the person, what is the purpose, for how long, and some other details, and this can be approved or rejected. And many of these requests are just rejected because those are just identified as commercial.
About data collection overview, you also mentioned about automated data collection and also unstructured data. You also mentioned circuit storage and analysis. It can be used for clinical and also maybe review this, but it's in form of digital collection, right? So how about field data collection? before it starts to be in the digital form? And are you also covering that in the flow, like library information management system via app or something?
So for the, let's say, real-time data collection, this is what you mean, right? So real-time data collection, we have support for that, but it requires a lot of overhead. So this requires like 24 hours. So some of our stuff, they are planned, they are supposed to work 24 hours. Because of this, if something goes wrong with data collection from a patient, that we should get some live data from some sensors. If something goes wrong, they need to fix that. So it's currently limited to clinical data. But I think they are doing some live collections for other types of data now, which is related to weather prediction. Because, for example, in Norway, for fishermen to go for fishing with their big ships in some specific parts of the sea, and if there is a storm coming, they need to have real life data, and this also processed at TSD. Yeah. So there are various types of real-time collection of data.
I see that we're eating into your break. So if you want, I would say that please go and have your breaks. For anyone that still has questions, I think we're okay with staying here for a little while. And then you can just come to us and ask your questions.